All right, so we're going to go through the first section of unit, oh, that only says Uni 8, not Unit 8 on the bottom there. We'll have to fix that in post-production, which is about logarithms. So we're going to talk about logarithms as inverses to exponential functions. So if you remember, if you're given the graph of a function, to get the inverse, you reflect the graph through the line y equals x. And what that means is you switch the x and y values. So on your paper down here, you're going to need to fill in each of these equations here. So anything that's got numbers in it, unfortunately, did not copy on your papers. So take a second and fill in everything that I've highlighted here so that you can get exactly what I'm talking about. And you'll notice that if you reflect through the line y equals x, these are reflections, and these are reflections over here. So what ends up happening is this is an exponential function that we've graphed before. This is a logarithm. Over here, this is an exponential function, and this is a logarithm. So algebraically, y equals b to the x, which you're also going to have to write down, is an exponential function. The inverse, which if we switch them around is x equals b to the y, is a logarithmic function. The equation x equals b to the y means y is the exponent on b to get x. So they're saying, what do you raise it to get that other number? It can also be written as y equals log bx, just like this. Make sure you make your b on the bottom there small as a subscript. It's tiny on the bottom. You're also going to have to write in these two things down here. Y equals log base b to the x means b to the y power equals x. Those are the exact same thing. So we're going to go through really quick how to do what's called a change of base. So these two examples here. The first example, again, you're going to have to write these down because they didn't come out on your papers. So the first one, f of x equals 4 to the x. Well, the first thing we want to do is we want to change this to y equals 4 to the x. And then to find inverses, you want to switch where things are. So this becomes x equals 4 to the y. Now the only way to solve this for y, because that's the next step, is you have to use a log. So you're actually going to write log. Our base here is 4, so it's going to be a little 4 down on the bottom. Our number on the other side is going to be x, and that's going to equal to y. So we have log base 4 of x equals y. That is, whoops, that is the inverse function of f of x equals 4 to the x. Doing the other side here, we have y equals log base 5 of x. So what you want to do, very similarly, first thing you want to switch is your x and y. So we have x equals log base 5 of y. And you'll notice that I'm saying it very specifically. I keep saying base 5. That means that whatever you're doing, your base is going to be 5. So now we need to figure out what our exponent is going to be and what's going to be on the other side. So the exponent is what ends up on the other side of the equal sign right here. So our exponent is going to be x, and y right here ends up being what it's equal to. So y equals 5 to the x is the inverse. Now the way that I remember this is a little bit different. I don't use x's and y's in it. I remember that ben, so base to an exponent equals a number, some number. So Ben. Well, Ben got arrested for using a log for B N E. B and E is breaking and entering. So Ben used a log for BNE. This is the way that you remember to change things around. So going from one side, which is exponential, to the other side, which is a logarithm. So we are definitely going to practice this some more tomorrow. So make sure you've gotten all the things written in that you need from the graphs, that you completed 2 examples, and definitely make a note of this whole thing right here in your notes, and we'll practice tomorrow. Have a wonderful night.